The textbook for the class is this book. It is a computer organization by Hamacher. This book is used last year by Ajahn Sanan as well. I know last year Ajahn Sanan has materials for many different textbooks, so many of your senior didn't buy a book. For me, to make it easier on you, I use mainly material from this book, so textbook will be very helpful. The grading, we'll do a midterm which worth 30%, a quiz 10%. We'll have bi-weekly homework, probably every other week homework for 20%. That's not a final project, a final exam. A final exam for 40%. Normally when I give an exam, it's either be open book or you can bring in one sheet. You can write anything down in one A4 paper. So far I have never done a totally closed book exam before, but we'll see. I haven't decided yet. But most likely I'll allow you to bring in one sheet and you can summarize the note and everything in. Okay? Which means there won't be too much of exam questions that remind you to remember stuff. Course material, you can go through it yourself. It's pretty much covered most of the chapters in the books, although not all, but most of the chapter. So the first lecture will be Introduction to Computer, which is basic knowledge that I assume you know, so I'll go through relatively fast. Second lecture, which we'll do today as well, will be about number representations. And that also, you have taken discrete math from Ajahn Narimon before, so this is the old material for you. So we can do this too relatively fast. Agree? Okay. Chapter 3, or lecture 3, we'll do instruction sequencing, assembly language. Now, as you can see that, chapter 1, chapter 2, and I skipped chapter 3. Chapter 3 is example machines, example platforms. I do expect you can read chapter 3 yourself. And then we'll talk about chapter 4. We skipped chapter 5 because memory is probably the most important thing in computer architecture, and we'll do that after midterms. And it will be, I will emphasize on that chapter after midterms. And then we'll do computer arithmetics and processing units. Another important material after midterm is pipelining, and then chapter 9 and 12 are mostly, banyai material. Okay, so this is the syllabus. Any questions, or am I speaking too fast, or anything, you can let me know. Okay, if I start to talk too fast, you can raise your hand and let me know, because I tend to pick up speed once I, start talking. Anyway, so that's it about the syllabus. Any questions? Which week? The midterm is here, so that is for midterm. And this is final, so this is for final exam. I don't think I'll do chapter 10, so we'll just do chapter 9 and chapter 12. I'll just be describing stuff. Chapter 12 actually has some network protocols, a little bit, advanced for computer architecture. Advanced computer architecture. We'll just talk about that. Most of the material I discuss in class can be in the exam, although all of it might not be, but all of it can be in the exam. Let's start talking about what is a computer before we start talking about its architecture and organization. So what is a computer? Well, a computer is basically a fast electronic computing machine, right? Computer is a fast electronic computing machine. So what is computer does? Normally what computer does is it processes digital information. Digital information is binary format, which contains only 0 and 1. So that's all what computer know how to do, is to process digital information according to store instructions or computer programs. So a computer program is basically a list of stored instruction. We'll learn about instruction probably next lecture about what is computer instructions. Computer programs is a list of stored instructions that process on a digital information. Now, when we say stored instructions, it means that these instructions are stored somewhere, right? So where is it stored? I'm sure you know the answer. It helps if you try to answer and participate a little bit, help your English and all. So where do we keep computer instructions? In a computer system, which device is used to keep instructions? Memory, right? So memory is used to store instructions, data, and everything. It is basically an internal storage. Reside on a processor board. The main memory is basically the RAM. Okay. Now, how many types of computer did you know? We have a personal computer. What else? We have a notebook. What else? Yes, we have a workstations as well, a server, a mainframe. There are many different types of computer. They all have different architecture. Okay. So next, let's talk about a basic functional units in the computer. So this is called a basic functional units. Computer obviously has more than this. If you ever open a processor board, the green thing inside the computer, you know there's a lot more. But mainly it has a arithmetics and logic unit. This is called an ALU, which is used to compute. It has a control unit, which control or coordinate the actions of the rest of the units. These are built on a processor. We have a memory unit. Memory has the whole hierarchies. It starts from the fastest memory is register, and then cache, memory. Cache has different cache, L1 cache, L2 cache, and then main memory, and then hard disk is the slowest type of storage, or we call it secondary storage. And then we have an I/O unit. I/O unit is input and output unit. Can you give me any example of the input unit? Yes, a keyboard, a mouse, a joystick, if you play games, so on and so forth. An output unit would be a printer, right? A monitor, everything that display output. So these is the basic functional units that most of the computer would have. Well, let's talk about one at a time. Input. And I say input unit accept coded information from operator. And operator can be human, can be device, can be machine, right? So that is the task of the input unit. Memory is used to store information, as I told you before. Then we have the arithmetics and logic unit. An arithmetics perform unit. It will perform all the digital operations defined in programs. So that's 1, 2, 3. The fourth unit, the output. These are devices that present results. And the last, control units. Okay, now let's talk about two important things, data and instructions. They're